Hey guys, Mr. Backerberg here. In this video we're going to look at operations with complex numbers. As we're looking at adding or subtracting a couple of complex numbers. So let's say for our first complex number in general terms we just had a plus bi, and we were going to add on another complex number. So let's call this one c plus di. The way addition works is we want to look at the real number pieces separate from the imaginary pieces. So since we're adding, what we would do first is add together the real number pieces, so in this case a and c, and then we would look at the imaginary numbers separate. So in our first complex number we've got the bi, and in our second complex number we've got di. What we would do is add those coefficients, so b plus d, and we would keep the I on that. And it would work similarly for subtraction as well. So if this was a plus bi minus c plus di, we would do the same thing. So we would first subtract the real number pieces, so a and c, and then we would subtract the imaginary pieces. So bi minus di, we would take b minus d and keep the I on there. So we're treating them kind of like combining like terms. So in this first example, we're looking at adding a couple of complex numbers together. We've got 7 minus 3i plus 4 plus 5i. We said we were going to look at the real numbers first. So we've got 7 and 4. We're supposed to add those together. So 7 plus 4 is 11. And then we're going to look at the imaginary number separate. So we've got negative 3i, and we're supposed to add 5i to that. Well, if we think about just combining those, negative 3i plus 5i is 2i. So we end up with 11 plus 2i. In our next example, we're supposed to do a little subtraction, so 2 minus I minus 8 plus 3i. Again, dealing with the real numbers first. 2 minus 8 is negative 6, and negative I minus 3i should give us negative 4i. So we get negative 6 minus 4i. Now multiplication maybe gets a little bit more complicated than adding or subtracting, but if we look at what we've got here, 2 plus 3i times 5 minus I. This looks sort of like multiplying some binomials together, so we're going to treat it like that and do some foiling. So the first things we need to multiply together are the 2 and the 5. 2 times 5 is 10. Then we're going to take the 2 and multiply it by our negative I, so we get negative 2i. If we take 3i times 5, we're going to get plus 15i. And then if we take 3i times negative I, we're going to get negative 3i squared. Now there is going to be some simplifying that we can do here. What we have to remember is that I squared is the same as negative 1. So in here, with this negative 3i squared, that's really like taking negative 3 times negative 1. So that's going to turn into a positive 3 on the end. We still have that 10 in the front. We can do a little bit of combining like terms with those i's in the middle. So negative 2i plus 15i gives us plus 13i. And then if we combine the 10 and the 3 together, we'll get 13 plus 13i. And we're going to write this in standard form. So we do want the real number to come first and then our imaginary piece to come second. Looking at this example, we're going to be raising a complex number to some different powers. So we know that z is the complex number 1/2 plus root 3 over 2i. And what we want to find is z squared. So what we're going to have to do here is take z and multiply it by another z. Well, we know that z is 1/2 plus root 3 over 2i, and we're multiplying that by itself. So another 1/2 plus root 3 over 2i. And we're going to FOIL this out just like we did before with multiplying. So we have to take a half times a half. When you're multiplying fractions, you multiply the top number. So 1 times 1 is 1, and on bottom 2 times 2 is 4. Then we're going to take the 1/2 times the root 3 over 2i. So 1 times root 3 is root 3. 2 times 2 is 4, but then we still have this I attached to it. And we're going to get a similar answer here in the middle when we take a half times root 3 over 2i. So we're going to get another root 3 over 4i. And then lastly, we're going to have to take the root 3 over 2i times another root 3 over 2i. So root 3 times root 3 is just a plain 3. 2 times 2 is 4. And then I times I is I squared. But what we have to remember is that I squared is the same as negative 1. So this I squared on the end is just like having negative 1 in there. So taking 3/4 times negative 1 is really like having negative 3/4. We still have the 1/4 out in the front. I'm going to combine our like terms in the middle. So when we're adding these fractions together, we add the tops. So root 3 plus root 3 is 2 root 3. We keep the denominator the same, so that's going to stay as 4, but then we still have this I attached to it. Now we can combine the 1/4 with the negative 3/4 from the back end, so that would give us negative 2/4. But negative 2/4 can be reduced down. That's the same as negative 1/2, and then we still have this plus 2 root 3 over 4i. We can do a little simplifying with the 2 and the 4 in here. So our final answer here is going to be negative 1/2 plus root 3 over 2i. Now let's say we wanted to take this one step further and find z cubed. So to do z cubed, we're going to take z squared times z. Now we just figured out what z squared was. It's negative 1/2 plus root 3 over 2i. And we already know what z is. We had that given to us earlier. That's 1/2 plus root 3 over 2i. So we're going to start multiplying this out. So negative 1/2 times 1/2 is negative 1/4. If I take negative 1/2 times root 3 over 2i, I'm going to get negative root 3 over 4i. Then if I take root 3 over 2i times 1/2, I'm going to get plus root 3 over 4i. And then lastly, taking root 3 over 2i times root 3 over 2i, we're going to get 3 over 4i squared. Now, nice things are happening in here. In the middle with the minus root 3 over 4i and the plus root 3 over 4i, those are opposites of each other, so those will cancel each other out. On the back end, remember that I squared is the same as negative 1. So taking 3/4 times this negative 1 in here, we get negative 3/4. We still have the negative 1/4 from the very, very beginning, and if we combine the negative 1/4 with the negative 3/4, that's negative 4/4, which just reduces down to negative 1. That's going to be it for this video. Thanks for watching.